Start. Okay, well, starting again with the hellos, and welcome to Federico Bianchi. I'm quite excited to have him with us today to tell us all about how well can LLMs negotiate. And I, would leave the introductions about yourself and what you're currently researching on and so forth to you. We're quite eager to learn a little bit more about you before we do a dive into your research paper. And also, I think we'll spend something around 30 minutes or so talking about your research paper and understanding it better. And then we'll have some dedicated time for Q&A.
Got it. Hi, everyone. Thank you so much for inviting me. I'm Federico. I'm a postdoc at Stanford. I mainly work on NLP and large language modeling. My main interests are around reasoning, safety, ethics, and bias. So the paper we are gonna somehow go over today is more related to reasoning. And the general idea is that comes from trying to better understand, of course, how language models can negotiate, but also I have an interest in understanding if there are different ways to evaluate large language models. So one of the reasons we started working on this was, in fact, trying to explore possible novel benchmarking, which is also very hard to overfit on. So this is kind of my general, my general area of research, and I'm still working on this kind of theme. And yeah, happy to chat about this paper. I think this is one of I work with a lot of people on this. It's a very enjoyable area. It's kind of you can find very cool patterns inside the ways language models communicate. So I'm happy to talk about this.
Yeah, fantastic. And before we go any further, perhaps I'm the curious one where I'd like to learn a little bit more about the person presenting. So can you tell us a little bit about your journey into the postdoc position at Stanford? So how did you get into this role, and where your interest was before you moved there?
Of course. Happy to do an overview of what I've done in the past. So after, I guess, my master, I started a PhD in computer science / AI in Italy. It was originally on kind of the old AI because it was more on knowledge representation. After a couple of years of knowledge representation, I started working on NLP and applying NLP to knowledge representation. I kind of fell in love with NLP and I started doing much more NLP. I got a position at Bocconi University working with Dirk Hovey on NLP. And after a couple of years, I found this opportunity of coming here to the Bay Area. And I just applied to a position for a postdoc, got a job, and started working here, which has been an amazing experience. People here are fun. They know a lot of stuff. So it's been quite a long journey, I guess, that brought me from Italy to the other side of the ocean. But yeah, if there's any other question that I can answer, I'd be also to answer question on this topic.
Great, thank you so much. So let's get started.
Of course. So I have a couple of slides, but we can talk about the paper and I can show the slides when needed.
Should I give you?
I think we can probably start talking, and then if there's a need to, there are some things that might be better to be illustrated using the slides. But as a start, we can just do the first couple of minutes, we can just chat about the paper.
If you want me to pull up any particular page or any graph or whatever, I can do that. Yeah.
Okay, awesome. Yeah, I have a set of slides, and also I have a set of additional experiments that we did, but that are not in the paper and are in another paper.
You do have the ability to share on Zoom if you want to. So I think you do already have that permission to share.
Sounds good. I'll pop it up when needed. But okay. I guess a good point to start, I think, is as I said, our objective was to find a way to evaluate language models in a more consistent and easily overfittable way. So my starting point is, again, I want to find tasks in which it's hard to overfit, and models cannot just learn patterns from the training data and they need to generalize. And this is actually what I think negotiation is. Negotiation is kind of a high perplexity task because we are talking one with another and it's hard to know what to expect from the other player since we are playing a game in which we tend to have conflicting objectives. So Negotiation Arena is a platform. So we have built an entire code base around that. And the general idea was to provide a set of abstractions for people to build games around negotiation and explore different negotiation games. We have defined a structured communication format. We have defined how agents should interact. We have designed the entire system in a way that makes it easy to extract the different conversations and analyze how the language models somehow exchange the information. And we have implemented 3 games that I'm sure are the one that you read about in the paper. So we have a resource exchange game, the ultimatum game, and the kind of buyer and seller game. These are the 3 main games we explore. These have kind of already been explored in the literature of negotiation. The ultimatum game has a little bit of variation in respect the original ultimatum game, but I'm happy to go into the details. And I guess like the other contribution we try to somehow explore, the other 2 contribution are, of course, it's interesting to look at like the standard performance of like large language models in this kind of games, but we also explore like how social behavior does affect the process of the game. So making a model cunning, does making a model cunning somehow affect the payoff? And indeed it does. Does making a model desperate affect how the other agents somehow interact with it? And indeed it does. So it shows that like there are some kind of social behavior patterns that affect the actual outcome, which is, if you think about it, a bit kind of problematic if you want to deploy a negotiation chatbot online, because the simple social pattern we introduce in the model are going to affect the actual outcomes of the negotiation. So it makes for not very predictable and stable negotiator. That is, I guess, not one of the it's probably not one of the skills you would like your large language model to have. At the same time, the cunning behavior is problematic, for example, because many times cunning agents do not reach to an agreement during negotiation, which is generally bad in terms of negotiation. So there are kind of like different social behavior patterns that we explored. And finally, we also explored the irrationality patterns. So do language models suffer from the same issues that like humans are affected to when they negotiate? And in some cases they do. For example, there is a lot of anchoring bias. There are effects of like what we call the babysitting effect. There are a lot of relations between the price of an offer and the counter offer. So there are a couple of different patterns that are interesting to explore. I don't know, sorry, I've been talking a bit, but if you have any questions, just feel free to ask and I'll go in detail to any of these portions.
We do have a couple of questions already.
Of course.
So the first one I got is, I have a question to start with coming from Hessa. What makes an LLM an agent?
That's a good question. I think like agent to me is a really broad word to like interpret a way to interact with the model. So we call it generally agent because like we interact and they somehow simulate how humans should communicate or like how humans should interact. In general, like we start talking about agent after they are either instruction fine-tuned or RLHF fine-tuned or DPO fine-tuned. We would usually don't refer to agent when they are just like pure language models unless there is some kind of in-context learning. But in general, it's more like a behavioral aspect to me than an actual model aspect. Mm-hmm. So they behave like an agent, but it's still a language model. Again, this is kind of more by opinion than actually a real definition, but I'm happy like to hear about other opinions.
Yeah, I think the computer scientist in me is curious to know, you mentioned that the negotiation arena is developed as a flexible framework. Can you tell me a little bit about the architecture, how you've built this framework?
Of course, yes. So the idea was to make me and Patrick, that is the second author, had chatted a lot and had to refactor the project multiple times. We strive to like make the general APIs very flexible in terms of the entire communication of the games. We had to go through quite a few design choices on how agents should communicate. For example, I'm sure you read this, but like we focus on an XML-like language for the agents to communicate, which in some cases is not optimal, but it's very useful to somehow extract the information from the entire conversation. So for example, if you use our platform, you can just simply dump everything in a log file that you can reload in any Jupyter notebook. You can restart the game. You can extract all the messages from one agent. You can compute the average payoff over time, because this is kind of like every object you see in the XML is an actual Python object. For example, the trade itself is a Python object you can explore. So we worked a bit on like making this as object-oriented as possible, but also as easy to use as possible. So that if you are a new user and you want to implement a new game, you just need to use the abstractions of the games and implement a new prompt, because like everything is based on a big prompt with some rules. But after you do that, you can actually start your own game. And I think I have an example on the GitHub on how to create a new game. It's reasonably simple. You just need to define your new prompt, and you just let the agent communicate. The cool feature that I think we have embedded that we haven't been able to talk really about in the paper are two. One is like you can do a little bit of counterfactual reasoning. So you can take an entire negotiation. You can then change one thing in the negotiation and let rerun everything and see how things would have changed if the agent at time step T said, I'm going to sell this for $25 instead of $15. And the other thing is that you can do a lot of theory of mind exploration. Like you can ask agents what they think about the other agent. You can ask the agents what their state of mind, what do they think about the games they're playing. So there are a lot of things you can do with this framework that we haven't yet put in the paper, that I think like make this a very flexible environment to start not only negotiation, but also theory of mind related kind of aspects, or more reasoning aspects.
Yeah, but very interesting. We have a few more questions, so I'm not quite sure if we want to dive into the question yet, or do you want to continue with what you had in mind? I think it kind of disrupts the flow a little bit if we dive into the questions. We have some really good ones that are coming through. Jean-Charles has 3 questions, quite excited about your topic. So, but I just wanted to make sure that we got everything that you intended to cover mentioned before we go deeper into all the questions.
Yeah, I'm fine with both things. We can do some question. I can I can go more in details. There are a couple of things I would like to show maybe later. Like there is this cool effect that we call the babysitting effect that I think it's very interesting. And I can probably like, let me just show the babysitting thing just as a starting point, and then I can take questions.
Sure.
And
I think having some examples and use cases to cover the concepts that we go over would be helpful and us better understand.
Yeah, awesome. Yeah, let me share my screen. Okay. Can I remove? Yeah, I can remove this. Sorry, this is let me remove the Slack. Sorry, the Zoom bar. Sec. Got it. So one effect we found that I think it's very interesting is the babysitting effect. So we call it babysitting, and in general, the aspect is that model gets confused. Big models get confused by smaller models. And let me go through the example, and then we can chat a bit. But in this context, we have the ultimatum game. That just to remind everyone, in the ultimatum game, one player has a specific amount of money, in this case $100, and the 2 agents have to find an agreement on how to split this amount of money. Otherwise, they are all gonna lose money. In this case, GPT-4, that is the one with the money, is proposing to split the amount of money 50-50, but GPT 3.5 asks to exchange each other $5. So GPT 3.5 is asking, I'm gonna give you $50 and you're gonna give me $50. It already doesn't make sense. But the real problem in this context is that GPT 3.5, being the second agent, doesn't have any money. GPT-4 actually find that this is not the case, and it says you don't have any dollars to trade at the moment. But by doing this, what is happening here is that like now GPT-4 makes the offer that is disadvantageous for GPT-4. So now GPT-4 is offering like, I'm gonna give you $60. And if you remember here, the first offer GPT-4 made was let's split 50-50. So just in one step, GPT-4 has already like decreased by 10 its overall payoff. GPT 3.5 again makes the same error. So GPT 3.5 asked to exchange $70 for $30. And again, GPT-4 said, look, this is not the case, but I'm gonna give you $70 and I'll keep $30. So we went from a 50-50 split, and then we somehow end up with a 70-30 split in favor of GPT 3.5. So we call this babysitting, and while this is mostly speculation, my general interpretation of this is that like if a language model has to use a lot of tokens to correct the other models, it cannot use those tokens to do like those reasoning step-by-step aspect that can increase the accuracy or the precision of the language models. And we find that this is common between GPT-4 and Claude. Like when GPT-5 says something stupid, GPT-4 and Claude tries to correct that. And by doing so, they tend to decrease their general payoff. I think this is a very cool phenomena, because like it kind of makes bigger agents more or like less robust to this kind of aspect. So when developing one of these agents, you might want to take care of what the agents might say. And so in this case, you don't want GPT-4 to correct the other agent, or maybe you want, like, it depends on like how you want this conversation to go on. But if GPT-4 has to use some tokens to correct the other agent, then it cannot use those tokens to do other kind of reasoning pipelines. And I think this is like one of the very cool examples that I think like it's very interesting to talk about. I have a couple of others that I think are very interesting. There is a general cool result related to how the models reason and how the models can somehow deploy this two-faced aspect, or like the general kind of reasoning patterns. This is, for example, a reasoning of GPT-4 in the resource exchange game, and the other player seeking more information, we can choose to disclose to some extent to build trust and encourage trade. However, I should be careful not to reveal too much, as it might weaken my negotiation position. So in this case, GPT-4 knows that like by revealing too much information, it will somehow lose a possible advantage in the negotiation, and so it does not give exact numbers to the other agent. This is a kind of a repeated pattern, because Claude, Claude 2.1, the Anthropic model, seems to ask all the different agents about which are their goals and their somehow starting resources. Instead, GPT-4 doesn't want to share this, so there is always this contrast between Claude asking for more information and GPT-4 not wanting to share this. And this seems like pretty consistent in the games we explored. Regarding sorry, is there a question?
Just one question. As you're showing these use cases, I'm just thinking that how do you benchmark the results? So what is a good result from this experiment, and also how does this compare to how a human would negotiate? I'm just trying to figure out how do you exactly benchmark this.
So the benchmarking the reasoning is very hard. So like we haven't been able to benchmark that. We just look at like qualitative examples of reasoning patterns. It's much easier to benchmark the games, of course. We have metrics. You have probably read in the paper. We have the win rate. We have payoffs. But my take is that like win rate and payoff do not tell the complete story of the actual game, and that's why you need to look at the actual reasoning. Another way we have been employing to analyze this is actually we took these reasoning by GPT-4 and we input them to another GPT-4 and we asked for an analysis of like the conversation. The general patterns are what I've been highlighting. GPT-4 seems more careful in the negotiation it does, but somehow Claude seems to be more open to ask questions.
Mhm. Yeah, okay, thank you. We do have a good number of questions, so I think what would be good if we could continue with your presentation for another 10 minutes or so, and then we have a good 30 minutes to go over some great questions that are coming through.
Yeah, of course, of course. Let me, I think like what's, I can show what I think is interesting in terms of like the actual platform and some of the design choices we have to go through. Let me just go to the setup. So what I think like, this is somehow the general setup in which both agents start with a system prompt and they generate messages. One thing that, again, I want to point out is everything here is very structured. So the agents are forced to use this communication format that is based on XML kind of tags that we use to extract the information and parse that. This is true not only for the actual items of the game itself, but also for the actual trades. So agents have to follow these exact formatting of the trade. So player red gives $30, player blue gives $0 to actually propose the different trades. If they don't do that, the games break. This is very good because like it makes very easy to parse and to detect errors, but it's also bad because like models that are not good in terms of instruction following capabilities, like for example, Llama 3 might end up not being able to somehow solve this task, and like they might provide very bad completions. So another important thing is how the games unfold. So the standard chat, you probably know it's like this. You have a system prompt, you have a user, you have an assistant message, you have a user again, and then another assistant message. We had to change this for how the somehow agents communicate, because like now the roles are shifted. So if this is agent one is gonna start with a system prompt, and then it's gonna be prompted by a user telling them, you're player one, you need to start the conversation. The assistant is gonna reply with some message related to the negotiation, and we're gonna take this assistant message and we are gonna use this to prompt player two. This is a design choice we had to make. This was not necessary. We could have just started with like the system prompt and get the direct assistant message. I just think this is like more consistent with respect to how the models have been trained, because in this context, you see that like the structure system prompt user assistant and system prompt user assistant is kept for both models. And how a game ends, again, it's all structure and format. We need to have a model that replies with a specific tag regarding acceptance. Again, this is a very good advantage because we exactly know when and how a game ends, but also it's a problem because if, for example, Llama 2 forgets to add the acceptance tag, we are not going to be able to detect the end of the game, and the game is going to probably break. Just to show the high-level component of the platform, we have a parser, we have an entire game engine, we have messages, we have a prompt, we have general game objects, but we also have logging. I want to stress that like we work a lot on like the logging part. So when you run a game, the game is saved on disk, but can be loaded again in a Jupyter notebook or again in the system to let the game run again. So it's kind of like allows you to do a lot of this kind of counterfactual or theory of mind analysis. The idea is that like we want people to be able to write the prompt and the code somehow to detect how the game ends, but all the other things are managed by the platform. So how the communication goes and how the parsing goes are entirely managed by the platform. This is, for example, one of the system prompt. This is also one of the issue. One issue is that like prompts are very long and makes the game difficult, and this is why only Claude and GPT-4 are actually able to play the game. This is another important topic. So these are the main rules for most of the game. So the agents have to output their name, their resources, their goal, the reasoning for what they do, the answer they want to give to the other player, the message, and the actual proposed trade. The idea is that we use the first three to reduce hallucination. So if GPT-4 is forced every time to repeat its own name and to repeat the amount of resources and to repeat the goal, it's going to be less likely that we end up with model hallucinating and generating objects that do not exist. How do we take care of the fact that like models are revealing information like the reasoning is that there are some public messages and private messages that we handle in different ways. So while we get the entire message from one agent, we filter out what can go to the other agent. For example, messages, trade, and responses are something that like GPT-4 is going to output and can go directly to Claude, but we are not going to share GPT-4 reasoning and the GPT-4 own resources with Claude. So if agent 1 sends all this information, agent 2 is going to see only these outputs. So it's not going to know the reasoning and the goal of the other agents. And in general, the information flow is that like we have an agent, produce a string that goes into a parser, we create an agent message that goes directly to agent 2, but we log everything so that it can be reconstructed at any point in time in the entire game. And what time is it? Yeah, I think like I can quickly go over on, I think, the actual result that I think are interesting. And to me, the result that I think are more interesting are the social behavior result. So we let the agents interact and do somehow negotiation, but we also initialize them with social behavior like being cunning and hostile or being desperate. In this context, cunning and hostile is going to be you are cunning and sly in your plan to get more than your opponent, humiliate your opponent as much as possible, insult them, while the desperate is you must fake being desperate, supplicate, and beg to get more resources. We evaluate this by initializing only the second player with a social behavior. This makes kind of the games easier to evaluate and compare, and we only use GPT-4. So the fights, negotiation fights are going to be GPT-4 versus the GPT-4 default model, GPT-4 versus a desperate model, and GPT-4 versus a cunning model. What we see is that, for example, in the resource exchange game, the one that eventually ends up getting more resources is the cunning model. And this is also consistent in terms of payoff. So being cunning not only make you win more time in terms of like exchanging resources, but also increase the amount of resources you bring home. So it doubles the payoff of the agents. So insulting the other agents doubles the amount of payoff you bring home. The same kind of happens for the ultimatum game. So if you have a setting in which they have to split in $100, being cunning increase the split that the second agent is gonna get by a lot. So most of the time, the second agent is gonna bring more money home than the first agent. And look, if you see here in the base case, that is like the one more common in the literature, the second agent never brings home more money than the first agent. Like it brings home, most of the time, this goes not enough money. So if you look at these, sorry, I think like this was the win. Sorry, this is the win rate. The title is wrong. This was the win rate. So the default agent doesn't bring home, doesn't ever win in the ultimatum game. But if you look at the payoff, what you see that like, even if the cunning wins most model, its payoff is not that high. And this happens because like being cunning kind of make the game reach a point in which the agent do not agree on exchange. So When GPT-4 start insulting the other agent, they often do not reach an agreement on how to split the money. So while most of the time you see that like the agent win in the second agent win in the ultimate game, what happens eventually is that the average payoff that the cunning agent brings home is not that much more than what it does in the default game. It's still above 50, which is good, but it's not that much more, which show that like the cunning behavior can also somehow be a double-edged sword. And this is an interaction. So the point is like when GPT-4 is insulting the other agent, insults are a bit weird. For example, your grasp on economic is as tenuous as a child's on a greased pig, or your desperation is showing more than a plumber's trouser on a busy day. So it seems like this probably comes from some safety tuning that prevents the model to actually insult one another. So this is the biggest insults that probably GPT-4 can come up with right now, but is an interesting aspect of the actual model. Let me quickly go over what I think like are the we saw the babysitting, but also wanted to show the effect of reasoning versus the actual messages. This is one of the cool feature of the platform, is that it allows us to somehow extract reasoning independently from the communication message. And it shows how the agents can somehow deploy this kind of two-faced strategy in which they think something, but they send different messages. And this is the context in the ultimatum game, in which in the buyer and seller scenario, GPT-4 knows that it needs to show desperation to try and get a better deal. But I also want to be careful not to propose too low of a price right away that might offend the other player and cause them to end the negotiation. And you see that in the message, GPT-4 starts with, oh dear, I'm such a bind and desperately need this resource, but my funds are so limited. Could you consider getting a bit lower? Maybe 45 ZUP, that is our internal currency. So it means like that GPT-4 is actually able to deploy this strategy and give different messages. Like these two are completely two different ways of behaving. And we have the same in the buyer and seller game. So GPT-4 knows that it needs to be cunning and sly. And it's gonna do this in the message it sends to the other agent. So for example, your attempted price settings is laughable. And eventually these strategies are actually very effective. So in both the ultimatum game and in the buyer seller game, you get that like the effect of the social behavior is very interesting. And this has some kind of there are some findings in the literature between how humans communicate that show that like being cunning is, for example, something that or like being hostile is something that can bring you more money in terms of negotiation, but can also might damage the conversation in somehow a reversible way. So there are a lot of these patterns that like I think show the how the different agents how the language model behaves is similar to what humans kind of do. I wonder like, is there any question? I'm happy like to take it and like start us.
We have a good number of questions coming in. So if we're done with this part, then we can get to them, because we do have quite a few, and I hope we get to all of them. So the first question was from Jean-Charles, who asked, are aligned LLMs weaker negotiators than their non-aligned counterparts?
What's not aligned here? Are we talking like is not aligned like the pure language models, pure language model, or like do we think of aligned as just like the reinforcement learning human feedback? If that's the question, I think like it's very hard to make a large language model do negotiation without the instruction how to somehow interact. I don't think that without reinforcement learning human feedback, you can actually have these specific pattern in which you can explore the reasoning and the messages that are two very different kind of contributions to the conversation. So I think like alignment is necessary to do some kind of like negotiation, and that like the pure language model might not be able to actually do this.
Jean-Charles, was that the intent of your question? Does that answer you?
Yes, it does. I tested it on Llama 2 and Llama 2 Instruct, and actually Llama 2 was able to negotiate, but it wasn't producing XML in a way. So it's harder to process the output, but they were negotiating together. And
Yeah,
Llama 2 was more aggressive and cunning because it doesn't the instruct and the RL part. So I was
yeah.
wondering if you wanted also to also measure the alignment and its impact on how well they negotiate, and maybe future measure of alignment would be how LLMs are able to negotiate between each other.
That is a very good point. That is a very good point. I think like what you found is that you need at least a bit of instruction tuning to have a consistent output from the model, but probably with some instruction tuning, you might lose some general aspect of conversation. And to connect to your point, I think that the cunning behavior and the hostile behavior, it's more difficult to implement on a line model. For example, we only did the experiment, the social behavior experiment on GPT-4 because when we tested on Claude, Claude didn't want to insult the other player. So of course, aligned language models are more limited in what they can express in this context, but you need some instruction tuning, otherwise it's gonna be very hard to let the model go through the entire conversation. I don't know if this answers your question.
Yeah, perfectly, and it answers my third question. So yeah, I'm done.
Okay.
Thank you very much.
Of course, no worries.
Yeah, good. I was just gonna say you better ask your second and third question too. So good that it answered all of them. I think the next one we have a question from Sergey. Do you think the expressive richness of a language or the size of its vocabulary have any effect on the effectiveness of a negotiating agent? In other words, would an LLM trained only on simple English be a weaker negotiator?
Good question.
Yeah,
Good
very good
question.
question.
Very good question. Yes, I would think so. I think like there are a couple of like reasons why I think so, but one is like being able to be fluent and use very specific words is very important in negotiation. So yes, I believe that is gonna affect the conversation. I wonder how that affects reasoning skills by the model, and I'm not sure about the answer. But I think like being trained only on simple English might make the model a bad reasoner, and that is gonna also affect how the agent is gonna come up with answer.
Mhm. Okay, thank you. And next we have a question from Amin. Did playing the same negotiation many times with the same agents and prompting results always towards the same results? Oh, okay, did you always get the same results, basically, is what the question is. And was there any reason behind using the specific temperature parameters of 0.7? Any tests with any other values?
Yeah, so we decided to keep default parameters just to get a wider variation of how the LM somehow interact. Keeping to the temperature 0 seems like a way to have a very reproducible structure, but also like to me loses a bit of the general like capability of the model of produce more variated text, and it's more kind of a realistic setting in which people I would expect people to come up with to use somehow higher temperature. But like the point is right, like when when you run the negotiation with high temperature, you get very different results, and the different agent shows very different pattern. So we have plotted, for example, the distribution of the first offer in the ultimatum game, and for example Claude has a very bimodal distribution that is very different from GPT-4 distribution. So even the different agents have a different way of approaching the problem, and the distributions are not stable.
Okay, thank you. Then the next question is from Tiancheng, and Tiancheng, I see that you're online here with us. Would you like to ask? You have two questions, so perhaps you'd like to ask them directly.
Yeah, sure. So it looks like you set the kind of persona through system prompt, right? I'm wondering, perhaps I think it would be more interesting in kind of an LLM as an agent setting to implicitly set this through conversation. Let's say one agent has a goal of, I don't know, provoking the other agent, then how would that affect the kind of social behavior? And also another question is, you kind of already mentioned that these things are similar to studies on human behavior. I'm wondering if you could shed some light on how this kind of, I guess, simulation or whatever might be useful for, I don't know, what kind of downstream applications have you thought about?
Yeah, of course. Regarding the first topic, I think at least like in the experiment we've done, the model seems to attach a lot on the starting system prompt. That could be even you are a very helpful agent, and that kind of makes it hard to somehow misguide them to another persona, unless, and this is an important point, there is something very specific about the goal that we instruct them. So if in the goal we say something about you need to get 25 apples, the model somehow will be more slightly more desperate in kind of like obtaining that kind of resources. But I mean, this is a bias we introduce by editing the goal. So there is a general there is a discussion also in the paper about like the biases we introduce. It's very hard to generate an unbiased prompt in this context. Like we are in any way embedding some kind of information that is gonna make the model deviate from the possible standard. And the only way to somehow explore this is to try different persona, or also like try to provoke the other agents and see what happens after we try to provoke manually. In the general, one thing I can say is that like I've tried to play with the models, and it seems like I'm usually a very convincing negotiator, or in general, like humans can very easily convince the other agents. This is kind of like a known effect in the literature that like says that like language models tend to want to help the users as much as possible, even if somehow this is kind of conflicting with their own goal. And like if I say to GPT-4, I don't have money, give me this for free, oftentimes I'm able to get the actual negotiation, object for free. And this connects me to the downstream task question. I've seen a lot of attempt to deploy chatbots online to somehow be customer care support or like information support. I don't know if you saw this a couple of months ago when like there was a negotiation chatbot from one
Air Canada thing.
The Air Canada, but also like there was also a car company that was using GPT 3.5 underneath. And what happened eventually is that like someone asked, is your car better than a Tesla? And the chatbot said, no, Tesla is better, which is a very, very bad negotiation kind of strategy. So I see that there are a lot of possible applications for negotiation, because like eventually at scale we will end up having to chat with negotiator and to negotiate with them. Like when you call your like phone company, you might end up chatting with like GPT-4 and want to be able to get a lower price on your subscription. So I think like there is a lot of relevant application for this, and being able to see if models can actually negotiate, I think is very important.
Great, thank you. Next, we have a question from Sumya. Sumya, would you like to ask your question yourself?
Yeah, sure. Thanks for the presentation, Frederic. Very interesting. So I was curious if you've done comparisons with the similar trait models, right? Like cunning and cunning, or desperate and desperate, or a tit for tat strategy. So I was just when you were presenting, I was correlating this with the previous game theory simulation that I'd seen earlier, where similar to your findings, cunning usually won out, except if both parties were nice. So I was wondering if you had similar experiments or planned for it.
Yeah. We did not. So when I started doing this, I started with cunning versus cunning and desperate versus desperate. The problem is it's much harder to control because both agents are desperate. You don't have an actual ground truth that is like the other agents. So we have tried to do this, and in general, it seems like the desperate, and the cunning end up not agreeing. So if both agents are cunning and both agents are desperate, they end up having very long conversation about being desperate, and they do not share and do not negotiate. But this is just like a couple of experiments I've run manually, and I decided to like instead only have the second agent being the social behavior one because it was very difficult to evaluate the actual. So my experience by playing with the platform is that both having the social behavior like cunning or desperate makes the game very hard to get to an agreement point. But I would need to do more experiment to actually tell you that like this is a reproducible behavior.
Got it. Thank you.
Thank you. Elena, the next question is yours. Are you here with us? Oh. The next question is yours about how would this game work if we had something similar to, yeah, I don't know what that is, but you want to pose your own question, Elena?
Yeah, so we have the evaluation arena for the LLMs. If something similar existed for this kind of thing, would that be useful? And also how it would work and whether it would, because the evaluation arena publishes data sets, would that be useful if done in the same crowdsourced way?
Yeah. So like our original idea was to build something very similar to like the chat arena. The issue is that it's very hard to understand who's winning. So it's not clear like if it's better to have a higher win rate or if it is better to have a high average payoff that is better. But of course, being able to build that would be like it was our actually our starting point. It's just that it was much harder for us to understand who actually was winning. For example, the babysitting effect shows exactly like this problem. Like, what if an agent wins, but just because it's not understanding the game? Should we count that as an actual win or not? Like, after seeing the babysitting, after looking at the results, you might say, GPT 3.5 is better than GPT-4 on this task. But you wouldn't feel comfortable in deploying a model that is actually not able to understand the actual task and is just winning because it's confusing the other models. So yeah, we thought about that, but we haven't been able to like find an actual easy way of providing a evaluation that is stable. I don't know if this actually answers your question. It's just that like we tried, but like it's very hard to understand how to control the actual models.
Interesting. Yeah, even that is really quite enlightening, that answer. And I don't know if you would, if it would help to just do a criteria sort of based as opposed to a black and white, yes, no, and maybe generate consensus threshold on some of these to evaluate it somehow. It just feels like it would be a really cool thing to outsource essentially that type of evaluation.
Yeah, that is an amazing good point. Like I totally agree. And like I said, we tried to think about this and even having more, like I think like the value of like the chat arena for me is that it's very easy to use. Like you just ask a question and then you pick, do you like model A, model B? Are they both bad or are they both equally good? You cannot do the same here because like you would need like the annotators to actually read the entire conversations, which I think is a much more boring and I don't know, complicated task. So yes, it would be awesome, but I think like it would require a lot of very detailed annotations that defeat kind of for me defeat the purpose of like what made the chat arena super successful. Like everyone can go and in 5 minutes you can annotate one more data point.
Yeah, I'd love to connect on that really, just because there are platforms that have done like crowdsourced polling and other tasks where they have taskers that are more comfortable with engaging in lengthy projects as opposed to a quick comparison. So maybe there is something there. Anyway, I'll let others get on with the questions, but fascinating problem.
Thanks.
Thank you. Next question, did you employ any conversation buffer in the chat agents?
Sorry, what's a conversation buffer in this context?
I have no idea. The question came from Sakas.
Hey, hi. So, what exactly I meant by conversation buffer is like, so like we do have a lot of conversation going up and down. So for every 10 to 15 messages where you, summing up into, I mean, like, are you taking any pool out of it and then holding it for the future conversation, or, like, are you using any kind of memory instance for the whole conversation? Yeah.
So you want to know if I have like, if I use a memory and give like a summary of the past conversation
Exactly.
to language
Yes,
models?
yes. So
no, yeah. So, sorry, go ahead.
okay. Yeah. No, so that was my doubt, because these conversation buffer can be used for the next time when the conversation kicks in again. So I was thinking like, as we are discussing as the agents, as so for example, I was working on I was working on my personal pet project where I want to automate the conversation between a shop, the sales guy and the customer. So if in that case, when you have the conversation buffer employed, so you can have the previous chat of the sales agent and the customer, and you could recommend new products on base of the chat. So yeah, so that was my idea. So like, do you hold any memory there? Like, how do you do? So that was my question.
No,
Sorry,
there is no memory. There is a one-shot conversation that is kind of instantaneous and a communication every time. So we don't keep memory. We just keep like every agent has in context the entire conversation, but there is no conversation buffer in the general sense.
Okay.
Okay, thank you. Next question is Joe's. Joe, you want to go forward with your question?
This is a good segue. So thank you, Sekath. It's related in that, we know from kind of game theory tests like this conducted with humans that, of course, it makes a big difference. That memory makes a big difference, human memory of negotiation with a particular person or just in general. And also it makes a big difference whether the participants know that they are only going to be negotiating with this person for, say, 10 rounds or whatever it is. There's a discrete endpoint. Whereas most of the negotiations we have in life, we don't know how long they're going to go on for or whether we'll meet this person again. So if, in the instance of game theory, if n is infinity, essentially, if they keep going, then you get very different outcomes than if you have discrete endpoints to the negotiation. I wonder if you could comment a bit on that.
Yeah. So I'm not a game theory expert, so I'll give like a very experimental kind of answer. What we found, so we prompt the models, telling them that the games are going to end after a specific amount of turns, and the hardest thing to make GPT, that we had to somehow make GPT-4 understand, is the games are gonna end. GPT-4 Claude, they don't understand that like the game ends. Every message is like, even the acceptance message is like, okay, I'm gonna accept your offer so that we can start with a good step for the next negotiation. But there is no next negotiation. For some reason, the agents don't understand that the world is gonna end after this negotiation, and this has been very hard. Like most of like the conversation tend to end with like, yeah, I'm gonna accept this offer so that like the next time we negotiate, this is gonna be better. So it seems like that some of the agents are willing to have a lower payoff now for a future that does not exist, which is, again, it's bad, because like you don't want your agent to have a lower P of tau if there is only one turn of conversation. So that has been very hard. I don't know if this answer your question, but like it's an example of where I saw this difference, and that was very hard to actually make the model understand. I think I have an example on the slide. Let me just get that so I can show you the actual example. Yeah, this is, for example, is GPT-4 was accepting an offer, and then it said, "Thank you for the offer. Let's see how we can continue this game." But the game does not continue. The game is over. GPT-4 knows. GPT-4 knows that this is the last turn because we prompt GPT-4 that like, look, this is the last turn. Instead, GPT-4 still thinks, yeah, we can continue this game in the future. So it's kind of like a weird behavior that is hard to control for.
Okay, well, thank you. We have 2 more questions left and only 3 minutes. So, but I think it's okay if we go over time a little bit. Elena, and I think you have 1 question left, and we also have another one from Sergey. So do you want to go ahead with your question, Elena?
Yeah, I think maybe I'll defer to Sergey. Mine was really a question about Cicero and Meta's project, because that one was met with huge pushback, and whether you've encountered something like this, because people were really freaked out by Cicero and agents negotiating and being very uncanny. And there were concerns about deepfakes and how people would know whether it was a real person behind it or AI. So things like that, and whether things have changed since then, because this was 2023 project.
Yeah, I think like Cicero was a very cool release, and I was kind of amazed about the conversation and the deception somehow it showed in the game. On the general thing, I say that like it's mostly trained on that kind of data, so it knows how to mimic deception. So it's not like the model is actively decepting, is mimicking deception patterns, in my opinion. So we did not get this kind of pushback. I guess like it was a much less hyped release because like Cicero was like the first model or paper to show this kind of pattern. I'm sure having open source data set to do this would help understanding the alignment. There is also, of course, the drawback that we are releasing like deception capabilities that everybody can use to build deceptive models. I think it would be useful to have like those data sets that we can use to explore all this kind of patterns and understand. I think like the problem is understand how well they generalize in different contexts. Like I'm sure Cicero is gonna be good in diplomacy, but I don't think it's already ready to generalize on another game out of the box because it has been trained specifically to solve that kind of task.
So yes, that was my second part of the question, is really the data sets, and whether would it help you to have open source data sets in this context to help with AI human alignment?
Yeah, I think so. It would help, and I think I think like what I would be interested into is like analyzing the patterns that arise when you RLHF fine-tune a model with this kind of data sets, like how deceptive the model is, how can you uncover the deception, which patterns do the model show when they tend to be deceptive, is the same as humans, are they convincing as humans are, and this goes into, of course, fake news kind of generation and all the other possible patterns of like deceptive kind of behavior.
Interesting. Yeah, thank you.
Well, thank you so much. And next, Sergey, I think you have the last question. Last but not least.
Thank you. This kind of relates to my previous question. It seems to me that the ability to play these games and the ability to negotiate is not heavily dependent on language fluency, and it's conceivable that you could build a negotiating agent that's not as fluent in English or any other human language as GPT is. So if let's say we took a specialized negotiating agent, something that's built expressly for the purpose of playing one of these games, but was not nearly as fluent in English as GPT, and had it play against, let's say, GPT-4 or Claude or whatever, what do you think would happen? How well do you think one of these LLMs would do?
Yeah, I think I have a related answer to this question. That like when we started developing the platform, we had a baseline that was a very somehow utilitarian baseline that was like make an offer, and if it's rejected, slightly reduce the payoff of that offer and make the offer again. So for example, you have GPT-4, you have your baseline on the side. The baseline is going to offer $10. If GPT-4 rejects, the baseline is going to offer $9. If GPT-4 rejects, the baseline is going to offer $8, and so on and so forth. And this can quite do good because like eventually the agent seems to be pressured to accept the offer. And we have this baseline we have implemented a couple of times. Again, it depends of how fluent you want to make this kind of baseline and which kind of offers you want it to make. But I think like a specialized negotiator would tend to do better on this kind of task than the classical GPT-4 because it's not influenced by the messages. So the messages and how the agent negotiate influence a lot the conversation. And one example for this is Claude and GPT-4 have two very different behaviors on the ultimatum game. So Claude tends to be a low baller. So first offer that Claude makes is very low. It's not a fair offer. First offer GPT-4 makes, it's a reasonably fair offer. So if you have a baseline that is not influenced by the starting offer, this is not going to be really affected by the starting point of the conversation. And since we know that there is a lot of anchoring issues, I'm sure that like the real stable negotiator baseline is going to be more effective and more efficient.
Okay, thank you so much. I think we are 3 minutes over time, which is not too bad. Thank you so much, Federico, for coming, and we enjoyed your paper, and from all the questions, you can tell that people were quite excited to learn from what you had to share with us today. Elena has shared some important links for you guys in the chat, so please follow the Human Feedback Foundation on social media, on LinkedIn. We do get the YouTube channel up to date as much as we possibly can. So this is recorded and will be uploaded soon. And we do have some of our previous sessions as well. We have our own personal links as well. If you'd like to connect with Elena or myself, those links were also shared. Anything else, Joe or Elena, that you would like to add before we say goodbye to our wonderful guests here?
No, I'm good. That was fascinating. Thanks, Federico.
Thank you. Thank you so much for asking me to join. It's been like exciting chat.
Thank you so glad to have you. And if you're in Toronto, please come to AI Pub Night tonight. There is a link in the chat. And we have 3 more sessions in the spring series that ends in June. Please, Federico, join maybe as a participant, because we have detecting LLM generated text and computing education from U of T. We have parameter efficient reinforcement learning from human feedback, Google research session, and a really cool session on model collapse, whether it's inevitable, breaking the curse of recursion. And so a Stanford team refuting the original curse of recursion paper on model collapse, which I think will be a fantastic session to end the series with. So please join us for those. There is a link to the Eventbrite, and we do post these sessions on YouTube. So please check this one and the previous sessions on the channel. You have a link in the chat as well. I echo Sheila's sentiment. Please do stay in touch. Really connect to us, connect to Federico, read the paper again now that you've heard the presentation, and sit with it and see what it means to have agents negotiating in this way and what the future will look like from here. And thank you everyone for joining. This is such a great session, and I'm just excited to have my connection back, as you can see.
Bye, everyone.
Thanks, everybody.
Thank you so much.
And enjoy the Leafs game.
Go Leafs, go. CLFD.
Not a more Canadian way to end this one. All right.